Natural language processing, or NLP, is a fascinating field at the intersection of computer science, artificial intelligence, and linguistics. It focuses on enabling computers to understand, interpret, and generate human language. From the words we type in search engines to the voice commands we give our smartphones, NLP is everywhere. In this video, we'll explore how NLP works, its core concepts, and its impact on our daily lives. Let's begin by understanding what NLP really means and why it's so important in today's digital world. The journey of NLP began decades ago, with early attempts to teach computers to understand language dating back to the 1950s. Back then, researchers focused on simple rule-based systems, hopping to translate languages and answer basic questions. Over time, advances in computing power and the availability of large datasets transformed NLP into a sophisticated discipline. Today, NLP leverages machine learning and deep learning to achieve remarkable results. Let's take a closer look at how NLP has evolved over the years. At its core, NLP aims to bridge the gap between human communication and computer understanding. The main goals include enabling machines to comprehend text and speech, extract meaning, and even generate language that sounds natural. Whether it's summarizing articles, translating languages, or answering questions, NLP strives to make human-computer interaction as seamless as possible. These goals drive ongoing research and innovation in the field. Before computers can understand language, they need to process raw text. This involves breaking down sentences into words, removing unnecessary characters, and identifying the structure of the text. Techniques like tokenization, stemming, and lemmatization help computers make sense of language by simplifying and organizing it. These foundational steps are crucial for more advanced NLP tasks. Tokenization is the process of splitting text into smaller units such as words or sentences. For example, the sentence "NLP is amazing" would be tokenized into "NLP is and amazing." This step allows computers to analyze each part of the text separately, making it easier to understand meaning and context. Tokenization is often the first step in any NLP pipeline. Stemming and lemmatization are techniques used to reduce words to their base or root form. Stemming cuts off word endings, so running becomes run. Lemmatization, on the other hand, considers the context and converts words to their meaningful base form. These processes help computers treat similar words as the same, improving the accuracy of NLP applications. Part-of-speech tagging is a method used to identify the grammatical role of each word in a sentence, such as noun, verb, or adjective. This information is vital for understanding the structure and meaning of sentences. For example, in the sentence "the cat sat on the mat," NLP systems tag cat as a noun and sat as a verb. This step is essential for many advanced NLP tasks. Named entity recognition, or NER, is a technique that helps computers identify and classify key information in text, such as names of people, places, organizations, and dates. For instance, in the sentence "Apple was founded by Steve Jobs in California," NER would recognize Apple as an organization, Steve Jobs as a person, and California as a location. This capability is widely used in information extraction and search engine. Syntax analysis, or parsing, involves examining the grammatical structure of sentences. By building a tree-like representation of a sentence, computers can understand how words relate to each other. This helps in tasks like machine translation and question answering, where understanding sentence structure is crucial for accurate results. Semantic analysis goes beyond grammar to understand the actual meaning behind words and sentences. This involves identifying relationships, context, and intent. For example, understanding that bank can mean a financial institution or the side of a river depending on context. Semantic analysis is key to making NLP systems truly intelligent and context-aware. Sentiment analysis is a popular NLP application that determines the emotional tone behind a piece of text. Businesses use it to analyze customer reviews, social media posts, and feedback to gauge public opinion. By classifying text as positive, negative, or neutral, sentiment analysis helps organizations make data-driven decisions and improve customer satisfaction. Machine translation is one of the most well-known NLP applications. It enables computers to automatically translate text or speech from one language to another. Services like Google Translate rely on advanced NLP models to provide accurate and fluent translations, breaking down language barriers and connecting people worldwide. Text summarization is the process of automatically generating a concise summary of a longer document. NLP systems can extract key points or generate new summaries that capture the main ideas. This technology is invaluable for quickly digesting news articles, research papers, and lengthy reports, saving time and effort. Speech recognition is another major area of NLP. It allows computers to convert spoken language into text, enabling voice assistants like Siri and Alexa to understand and respond to our commands. This technology relies on complex models that can handle different accents, languages, and noisy environments. Text classification involves assigning categories or labels to text based on its content. For example, emails can be classified as spam or not spam, and news articles can be sorted into topics like sports, politics, or entertainment. This process helps organize large volumes of information and automate decision-making. Question answering systems are designed to provide direct answers to user queries rather than just returning a list of documents. These systems use NLP to understand the question, search for relevant information, and generate a concise response. Virtual assistants and search engines often use this technology to enhance user experience. Chatbots and virtual assistants are some of the most visible applications of NLP today. They use advanced language models to interact with users, answer questions, and perform tasks. Whether it's customer support or personal reminders, these tools rely on NLP to understand and generate human-like responses. Text generation is the ability of NLP systems to create new, coherent text based on input or prompts. This technology powers applications like automated news writing, creative story generation, and even code completion. Modern language models can produce text that is often indistinguishable from what a human might write. NLP relies on a variety of algorithms to process and analyze language. These include statistical models, rule-based approaches, and more recently, deep learning techniques. Each algorithm has its strengths and is suited to different tasks, from simple keyword extraction to complex language understanding. Bag of Words model is a simple yet powerful way to represent text for analysis. It treats a document as a collection of words, ignoring grammar and word order. By counting the frequency of each word, computers can compare documents and identify patterns. This model is often used in text classification and information retrieval. TF-IDF, or Term Frequency Inverse Document Frequency, is a technique that highlights important words in a document. It assigns higher scores to words that appear frequently in a document but are rare across other documents. This helps identify keywords and improve search results, making it a staple in many NLP applications. Word embeddings are a way to represent words as numerical vectors, capturing their meaning and relationships. Techniques like Word2Vec and GloV allow computers to understand that words like king and queen are related, and that Paris is to France as Rome is to Italy. Word embeddings have revolutionized NLP by enabling deeper language understanding. Neural networks, especially deep learning models, have dramatically improved NLP performance. These models can learn complex patterns in language data, enabling breakthroughs in translation, summarization, and text generation. Architectures like recurrent neural networks, RNNs, and transformers are at the heart of modern NLP systems. Transformers are a type of neural network architecture that has revolutionized NLP. Unlike previous models, transformers can process entire sentences at once, capturing long-range dependencies and context. This has led to the development of powerful language models like BERT and GPT, which set new standards in language understanding. Retrained language models are trained on massive amounts of text data before being fine-tuned for specific tasks. This approach allows models to learn general language patterns and adapt quickly to new applications. Pre-trained models like BERT, GPT, and RoBERTa have become the backbone of many state-of-the-art NLP systems. Transfer learning allows NLP models to leverage knowledge gained from one task and apply it to another. By using pre-trained models as a starting point, developers can achieve better results with less data and training time. This technique has accelerated progress in NLP and made advanced language technology more accessible. Search engines rely heavily on NLP to understand user queries and deliver relevant results. By analyzing the intent behind search terms and matching them with web content, NLP helps users find information quickly and accurately. Features like autocomplete and voice search are also powered by advanced language processing. Social media platforms use NLP to analyze posts, comments, and messages. This helps detect spam, filter harmful content, and understand trending topics. NLP also enables features like automatic translation and personalized recommendations, making social media more engaging and safer for users. In healthcare, NLP is used to extract valuable information from medical records, research papers, and patient notes. It helps doctors make better decisions, speeds up research, and improves patient care. Applications include automated diagnosis, clinical documentation, and patient sentiment analysis. Financial institutions use NLP to analyze news, reports, and social media for market trends and risks. NLP-powered chatbots assist customers, while sentiment analysis helps predict stock movements. By automating information extraction, NLP saves time and enhances decision-making in the financial sector. E-commerce platforms use NLP to power product search, recommendation engines, and customer support chatbots. By understanding customer queries and reviews, NLP helps personalize shopping experiences and improve satisfaction. Automated product descriptions and sentiment analysis are also common applications. In education, NLP is used to develop intelligent tutoring systems, automate grading, and provide personalized feedback. Language models can assess student writing, detect plagiarism, and recommend learning resources. These tools help teachers save time and support students more effectively. NLP plays a vital role in making technology accessible to everyone. Speech-to-text and text-to-speech systems help people with disabilities communicate more easily. Real-time translation and reading aids break down barriers, ensuring that digital content is available to a wider audience. Despite its progress, NLP faces many challenges. Language is complex, ambiguous, and constantly evolving. Sarcasm, slang, and cultural differences can confuse even the most advanced systems. Ensuring fairness, accuracy, and privacy in NLP applications remains an ongoing concern for researchers and developers. Language models can inadvertently learn and amplify biases present in training data. This can lead to unfair or discriminatory outcomes in NLP applications. Addressing bias is a top priority, with researchers developing techniques to detect and mitigate harmful patterns in language models. NLP systems often process sensitive information, raising concerns about privacy and security. Protecting user data and ensuring compliance with regulations like GDPR are essential. Techniques such as data anonymization and secure model training help safeguard information in NLP applications. Multilingual NLP focuses on building systems that can understand and generate text in multiple languages. This is crucial for global communication and inclusivity. Advances in transfer learning and large-scale language models have made it possible to support dozens of languages with a single system. Many languages lack large datasets for training NLP models, making it challenging to build effective systems. Researchers are developing new techniques to support low-resource languages, ensuring that NLP benefits people around the world, regardless of the language they speak. Real-time NLP powers applications like live translation, instant messaging filters, and voice assistants. These systems must process language quickly and accurately, often under challenging conditions. Advances in hardware and software have made real-time NLP more reliable and accessible than ever. The NLP community benefits from a wide range of open-source tools and libraries. Popular frameworks like NLTK, SpaSci, and Hugging Face transformers make it easier for developers to build and experiment with language models. Open-source collaboration accelerates innovation and knowledge sharing. NLP is part of our daily routines, often without us realizing it. From autocorrect on our phones to smart speakers in our homes, NLP makes technology more intuitive and responsive. As language technology continues to improve, it will become an even bigger part of how we live and work. The future of NLP is full of exciting possibilities. As models become more powerful and data becomes more diverse, we can expect even more natural and intelligent interactions with technology. Researchers are working on making NLP systems more ethical, transparent, and accessible to everyone. Ethical considerations are increasingly important in NLP. Developers must ensure that language models are fair, unbiased, and respect user privacy. Transparency in how models are trained and used is essential for building trust and accountability in NLP applications. If you're interested in exploring NLP, there are plenty of resources to help you get started. Online courses, tutorials, and open-source libraries make it easy to experiment with language models and build your own applications. Whether you're a beginner or an experienced developer, NLP offers endless opportunities for learning and innovation. Natural language processing is transforming the way we interact with technology. From understanding text and speech to powering chatbots and search engines, NLP is making computers more human-like every day. As the field continues to evolve, we can look forward to even more innovative and impactful applications that bridge the gap between humans and machines.